Assalamualaikum and good afternoon. So we're going to start our revision on multiple linear regression now. So can you hear my voice?
Yes, Miss.
Okay, thank you. Okay, last time we have discussed about simple linear regression. So now it's going to be another topic which is going to be on multiple linear regression. So basically, multiple linear regression is an extension of simple linear regression. Okay, let's have a look at what is the difference between them. Okay, for the case of simple linear regression, so what happens is that you have one independent variable and you also have one independent variable. So for which your model is going to be given by y equal beta naught plus beta 1 x. So the main point is that you're going to have only one x because you only will have one independent variable. So that is going to be the case of simple linear regression. So multiple linear regression, what happens is that you can have one dependent variable. So the y is still the same. There's only going to be one y. But now what happens is that you can have two or more independent variables. So instead of having only one x in your model, you can have more than one x. So depending on how many you have. For example, if you have three, then you can have x1, x2, and x3. If you have two, there's going to be only x1 and x2. Okay, so basically this is going to be our model. So beta naught is going to be still the same. It's still going to be the intercept of the model. And then we're going to have beta 1 x1. So this is going to be for our first variable. Beta 2 x2 for our second variable. And you're going to have that for as many variable that you have. For example, here, so this is actually wrong. I should have put a k over here. For example, let's say if you have k variable, so therefore this is going to extend until bk xk. All right, so basically what happened is that you have more than one independent variable. So that is going to be the case of multiple linear regression. So that is the characteristic of multiple linear regression. So which one is actually what do you call it, more applicable? So in terms of like real life application, so there are actually more model with multiple linear regression compared to simple linear regression. Of course, simple is easy, but it actually gives you an idea how do we do regression. Okay, so the idea of multiple linear regression is that we don't really do the calculation by hand. So the calculation is going to be very complicated. So considering that we have more than one independent variable to count in the model. So what happens is that, not most of the time, so all the time, multiple linear regression is done by using software. You can either use Excel, you can either use R, you can use SAS. There are multiple softwares that actually can conduct multiple linear regression. And this is going to be an example of an output from Excel because our syllabus concern output from Excel. So I'm going to show you how the output look like and how you actually read this output. Like how do you extract information from the output? And this is actually, I took this from the example in the slide. And if you have watched the video or you have read how you have gone through the slides, so you should be able to recognize that this come from those examples. Okay, so what happened is that I'm not going to discuss about the example. I'm just going to tell you, so where do we find the important values from the particular Excel output? Okay, now let's start with the regression statistics over here. Okay, the thing is that for this regression statistics, so we have discussed this during simple linear regression. So you are going to use multiple R to find what is going to be the correlation coefficient. So this one is going to be for correlation coefficient. So it's still going to be the same idea for multiple regression as well. So what happened is that if I have a value of 0.9867, so I'm going to say that we have a strong linear positive. So positive is missing over here, so you need to have positive. You need to say that it's going to be a positive strong linear relationship between the monopod sales, advertising expenditure, and population size. So basically for this case, this is going to be our dependent variable, and also these two are going to be our independent variables. Okay, basically, so the main idea that I want to tell you is that for the case of multiple R, so this is where you find the correlation coefficient. But the thing is that in multiple linear regression, we don't really care about correlation coefficient. We hardly ask about that. And then we have R square. If you notice, we have two types of R square. So the first is R square at the top over here. So it's a value of 0.97365 and the other one is right underneath, so which is called as adjusted R square. So what is the difference between R square and adjusted R square? So when you have simple linear regression, So what happens is that you only have one independent variable in the model. So when you wanted to find the R square, which stands for the coefficient of determination, so you are going to use this particular R square for simple linear regression, one independent variable. However, so when you have more than one independent variable, so which make your model into a multiple linear regression model, automatically you cannot use R square, but you have to pick the one underneath, which is the adjusted R square. So what is the difference between R square and adjusted R square? The difference will be in terms of the formula, because when we have more than one independent variable, so we have to do some little adjustment in the formula, so to consider the fact that we have more than one independent variable now. So that is why it is called as being adjusted R square. So bear in mind, simple linear regression, so you take the R square value. Multiple linear regression, you take the adjusted R square value. So that will be the difference. And if you remember, like when we discussed the test of linearity before, for which we use this particular ANOVA table, so we also going to have ANOVA table for the case of multiple linear regression. Okay, however, this is not going to be a linearity test, but it's more about like, it's sort of like a linearity test, but what happens is that we consider all of the independent variable. So for the case of this ANOVA table, so what is going to be what are we testing is going to be H null, the fact that none of the independent variables, so I'm referring to this hypothesis at the top. So for the H null that we were testing with this p-value is that none of the independent variable is related to the dependent variable. If none of the independent variable is related to the dependent variable, so basically our model is useless. So this is going to be a bad model. We don't want that model. Okay, so we don't want H null. And the case of H alternative is that, so it gives us an idea that at least one, so we don't know whether there is one, or there's two, or there are three independent variable that is related to the dependent, but what we know is that at least one of the independent variable is related to the dependent variable. So meaning that our model is, we couldn't say that it's good, but our model is actually what I call that applicable. So it's actually a model that we can use. However, if it's a bad model, so we cannot use it at all. Instead of like using writing it in terms of sentence, you can also use symbol. So for H null, so this is going to be our hypothesis in terms of symbol. We're going to say that beta 1 is equal beta 2 equal beta k is equal 0, if you remember. So this is very similar to our linearity test that we discussed last week. The only difference is that for linearity test, we only have one beta, so which is beta 1. So we write that beta 1 is equal 0. But now we have more than one independent variable, and for each of them, so we have a beta. So therefore, depending on how many independent variable you have, you are going to test on all the beta. For example, if I have 3, so I'm going to have beta 1 equal beta 2 equal beta 3. All of them are going to equal 0. Or if it's an alternative, I'm going to write that bj is not going to equal 0 for at least one j. So this is going to be our variable. So k is going to be the number of variable that we have. If there is like two variables, it's going to be j is just going to be 1 and 2. So if I have like for example 3 variables, I'm going to have j is going to equal 1 to 3 and so on. Okay, so basically k, so k is going to be number of variables, of independent variables that we have in our particular problem. Okay, so that is going to be the p-value. And then we also have this part over here, so which is the coefficient. So if we have output from Excel, so we can actually write our model and use that for prediction, because the value of beta naught, beta 1, beta 2 is already given. So this value, the coefficient, first coefficient is going to concern about value of the intercept. So we know that value of the intercept, that is going to be the value of beta naught. And then we also have, this is going to be our first variable. So therefore, this is going to be the value of beta 1. So this is going to be our second variable. So this is going to be our value of beta 2. So therefore, for this case, so if I want to write the model, so my model is going to be given by y is equal beta naught plus beta 1 x1 plus beta 2 x2, because I have two independent variables. So those are going to be my independent variables, x1 and also x2. And knowing that we already have this value, so we can simply substitute. So beta naught is going to equal 6.3972. For example, I'm going to take only 4 decimal places. So plus, so beta 1 is going to be 20.3972 0.4921 multiplied by x1, and beta 2 is going to equal 0.2805 multiplied by x2. Okay, so this is going to be our model for this case. So that's how you write down your model from the case of multiple linear regression. So basically the idea is very similar to simple linear regression. You only added up more terms to accommodate the other independent variables. Okay, so the model is actually written over here. So this is going to be our model. Okay, and then we also have this p-value right here. Okay, this p-value right here, so what does it concern? So it concerns about the linearity test. What we did in the previous simple linear regression. So this will be the same idea. So we are going to test individually. So we have two independent variables, so which is advertising and also population. So we test for each of the individual variable, so whether or not they are related to the dependent variable. Okay, so basically, if I were testing what I call that variable number 1, so this question mark over here is going to be 1, so I'm going to have b1 equals 0 or b1 is not equal 0. Remember, if b1 equals 0, so that means that the gradient is going to be 0. So this will be the idea of linearity tests. So what happens is that there is no relationship between the independent and dependent. But when we have alternative beta 1 is not equal 0, so the variable is significant. So meaning that variable is useful for the model. If it's H null, then it is not significant, it is not useful to the model. So if the question asks you, so which variable is significant? So this is where you should look for at the p-value. So you test for each of the variable, so whether they are greater than p-value or less than p-value. And because it's going to be significant for the case of alternative, so the variable is going to be significant. So when your p-value is actually less than alpha. So the smaller the p-value, so meaning that the higher the significance of the variable in our model. So that is what it means. Okay, and then in this topic also, so instead of like just interpreting the values and all, so you're also going to have to do model selection. For example, if you have one particular problem with 3 independent variables, so you have to pick, so whether should we include all 3 independent variables. So if you want to include only 2, so which 2 should we pick, and so on. So this is known as being the model selection. So how do we pick the best model? Because the question is going to ask you, so what is going to be the best model? So how do we pick the best model? So the first rule is that your model should have a very low p-value. So the smaller p-value, the better it is. So meaning that the one with the smallest p-value, so that is likely to be our best model. But it depends on the condition as well. There are many more factors that we have to count in. And then the second rule is that, so your model should have high R-square, because R-square is sort of like telling you the connection between the independent variable and the dependent variable. So the higher percentage, meaning that there is more, there is a stronger connection between the independent and the dependent variable. So therefore, so you want a very high coefficient of determination. But as I mentioned to you just now, so when you are looking for a model with only one variable, so you look at R-square. So when you're looking for a model with more than one independent variable, so have a look at the adjusted R-square. So that is where the value of coefficient of determination comes from. So the keyword is going to be adjusted. And the third rule is that you cannot choose a model with all the independent variables. For example, if I have 3 independent variables, so my model is going to be y equal beta naught plus beta 1 x1 plus beta 2 x2 plus beta 3 x3. So we actually don't want this model. Okay, so you want to pick a smaller model. So the model is actually, when we have a model, so we don't want many independent variables, because having many independent variables, meaning that you have a humongous data you have to take care of, and you also have to spend more to collect the independent variable. So therefore, so when you pick a model, so don't pick the full model. So the one that has all the independent variables, so that is called as the full model. So we wanted it to be smaller. And the last rule is that, so for each of the independent variable in the model, so each of the independent variable individually, so they must be significant. So what do I mean by that? For example, So if I have a model with 3 independent variables, so this one, so that's definitely ruled out. It's not going to be our model. But let's say, so I found out from my investigation, from our calculation, so the fact that the best model is going to be a model with x1 and also a model with x2. So I'll show it to you later. How do we actually figure out which one is the best? Okay, if I wanted to pick this model, I have to find from the output the fact that so x1 has to be a significant variable. So x2 is also must be a significant variable. And how do we find whether they are significant or not? So that is going to be from the p-value over here. So that tells you so whether or not the individual variable is actually significant. Okay, so that is going to be the rule of the model selection. So as long as your model is satisfy all these 4 conditions, then that is likely going to be the best model. So let's have a look at this particular problem. So this is from final exam, semester 1, 17-18. So the question says, in order to enhance the customer satisfaction, a supervisor in a supermarket conducted a study for the time a customer takes to check out after purchase by considering the total amount of purchase, so number of purchase item, and the customer's household monthly income. So basically, what is going to be our y variable? So our y variable is going to be the time a customer takes to check out. So when you go to the supermarket, you go to Giant, for example, so how long do you spend at Giant before you decide to go to the counter and buy whatever that you purchase? So that is what it means over here. So time for the customer takes to check out. So this is going to be our y variable, the dependent variable. And this dependent variable, so we want to know whether or not they are actually related to the first independent variable is going to be total amount of purchase. And the second independent variable is number of purchase item, how many items you buy. And then, so the third factor is going to be the customer's household monthly income. So the following Microsoft Excel output shown in figure 1 is a multiple linear regression analysis for the study. So based on data collected from 20 customers. So here we know that how many samples do we have? We have 20 samples. Or you can actually have a look at how many samples you take from the observation here. So this value of observation tell you how many n do we have. Okay, so now let's have a look at the question. So what does the question want? So the first question, it says test the hypothesis. So we know that when the question says test, this is definitely going to be hypothesis testing. So you need to have hypothesis, decision, and also the conclusion. So we're going to test the hypothesis whether there exists significant linear relationship between the customer's checkout time and the independent variable at 2.5 significance level. Okay, so here, so we want to test whether or not there is a relationship between dependent and the independent variable. So there is only one place for you to check that, only one p-value. So that is going to be for the multiple linear regression, it's going to be over here, so which is going to be on the ANOVA table. So this one, it's written as significance F, but basically this is going to be our p-value. So now I'm going to write the hypothesis. So this is going to be my H null. So my H null is that none of the independent variable is related to the dependent variable. So how many variables do I have here? I have 3. So x1, x2, and also x3. So therefore, if I want to write it in terms of symbol, I'm going to say that my beta 1 and beta 2 and beta 3 value, they are all equal 0. So none of them are related to the independent variable. Sorry, to the dependent variable. And the alternative is that, so beta j is not equal 0. So any of this, so one of them is not equal 0. So for at least one j, so I have 3 variables. So my j is going to equal 1, 2, and 3. So referring to what you have at the top right here. So that is going to be the hypothesis. Or if you find it confusing, you don't want to make mistakes in terms of writing what is the value of j and how many beta are there. So what you can do is you can write that in terms of words. So none of the independent variable is related to the dependent variable. So alternative, at least one independent variable is related to the dependent variable. So now that we already have our hypothesis, next step will be extracting our p-value. So p-value comes from here. So it is a value of 0.0000. But basically, when you write down 0.0000 here, so it doesn't mean that the value is actually 0. Actually, you could have like 10 zeros, then only you have one value. Okay, so that is why it's when you take 4 decimal places, then it's only written as 0.0000. So the p-value here, we are going to compare that with our alpha value. And for this case, our alpha value is 2.5%. This is not 0.25, that is 2.5%. So 2.5%, you have 2.5 divided by 100. So that is going to be a value of 0.025. So do not get tricked by something like this. So here, what will happen is that our p-value is smaller than our alpha value. And I have told you this before. So when we have p-value which is less than alpha, so therefore automatically what happens is that we are going to reject the H null. So meaning that H null is wrong. So H alternative is going to be correct. So if H alternative is correct, meaning that yes, so at least one of the independent variable is related to the dependent variable. So we're going to answer the question. So the question asks you whether there exists significant linear relationship, of course, because our model is not completely useless. So there exists significant relationship. So we're going to say at alpha equals 0.025. So there is a significant, so you just copy down the whole thing, significant linear relationship. So between the checkout time and the independent variable. Okay, so those are going to be our hypotheses. So we just want to answer this question. So you get B1 for this. So you get 3 marks for this. So writing the correct value of p-value, you will get 1 mark. So you compare the value and you decide to reject. So that is going to be another 2 marks. And writing the conclusion, so that is going to be another mark. So basically that is going to give you 5 marks already, as long as you know how to write the hypothesis and you know where to get the p-value. Okay, and next problem. So it says state the coefficient of determination. So the coefficient of determination, that's referring to R square, and then we have to interpret the p-value. Right. So where do we find the coefficient of determination? So as I mentioned to you just now, this is a multiple linear regression. So we have to use the adjusted R square, and that is a value of 0.7934. Let me see the output first. Okay, that's right. So here I have R square is equals 0.7934. And I did mention this to you before when we discussed simple linear regression. The idea is still going to be the same. That when you express your coefficient of determination, it has to be in terms of percentage. So even in terms of the interpretation, is still going to be the same. So I'm going to say 79.3% of the variation of the dependent variable, variation of y. So what is our y? So our y is going to be the checkout time. Variation of checkout time. So can be explained by x. And for this case, we have 3x. So we're going to list them all. Can be explained by amount of purchase. So these are going to be our variable. So amount of purchase, number of items, and household income. So amount of purchase, number of item, and household income. Okay, so basically how do you do the interpretation for coefficient of determination? So you just have to mention, so what is going to be the percentage of the variation in y can be explained by x. So this is fixed. So this is sort of like what I call a fixed way to interpret this. But the only thing that you have to do for each of the case that is going to vary is that you have to substitute what is going to be a y for that particular problem and what is going to be the x. So it's going to be the same for simple linear regression. It's going to be the same idea for multiple as well. The only difference is that for multiple, so you can have more than one x variable that you have to list out. That's it. So that will be the only difference. Again, then question number 3. So it says over here, so state the predicted multiple linear regression model. So I'm going to have y is going to equal. So this is going to be, we have 3 variables. So we know that the model is going to be beta naught plus beta 1 x1 plus beta 2 x2 and plus beta 3 x3. And where do you get the value of beta naught, beta 1, beta 2, and beta 3? So that is going to come from here. So these are going to be the value, so which is listed under the coefficients. So I already have the output in front of me right here, so I'm just going to refer to that. So for this case, we have that from the output, the beta naught, the value is going to equal 4.1350. Just copy it down. And beta 1, the value is going to equal 0.0229. So multiplied by x1. X is the variable. Y and x, you don't have to substitute. You only substitute the value of the betas. And then you have beta 2, that is going to be a value of 2.1825 x2, and the last one is a negative value. It's a value of negative 0.5445 and multiplied by x3. And as I mentioned just now, where do I get all those values? So the values is from here, 0.0229, 2.1825, and also 0.5445. So if it's positive, put a plus. If it's negative, put a minus. So that is going to be how you write your model. So based on the output given. Okay, question number 4. It says interpret the regression coefficient of the number of purchase item and the coefficient of the customer's household monthly income. Okay, what is the regression coefficient? So there are two types of regression parameter. First, regression constant. So regression constant stands for the beta naught. And then we also have regression coefficient. So regression coefficient is your beta 1, beta 2, beta 3. So the value that concerns the coefficient of the independent variable. So those are going to be regression coefficient. So what values do they want? Is it being requested in this question? So this question asks you to write the regression coefficient of the number of purchase item and the customer's household monthly income. So which variable is that? Okay, let's have a look at first the number of purchase item. So amount of number of purchase item is going to be here. So the beta, so I'm going to call that as beta 2. It's variable number 2. It's given by a value of 2.1825. So let me put over here. So that my beta 2, so the value is going to equal 2.1825. So it concerns about the number of purchase item. Okay, however, when you interpret for the case of simple linear regression, you can interpret straight away. You don't have to have any additional information. But when you interpret for multiple linear regression, so that is going to be one important sentence that you have to include. So which is going to be this, which is holding other variables constant. Okay, so for simple linear regression, you don't have to do this because you only have one variable. But for the case of multiple linear regression, you have to assume that, so this is going to be the value when other independent variables are constant. You don't change the other independent variable. So this is what happened to this particular variable. So therefore, so this sentence over here is going to be compulsory when it comes to interpretation. So if you don't have this particular sentence, particular words included in your sentence, so automatically your interpretation is going to be invalid. So make sure it's there. So we have that beta is going to equal 2.1825. So I did mention to you before when we discussed simple linear regression that how do we we interpret the gradient. So the value of gradient, the interpretation is that, so how much y change, it's going to be something like this. So when x increased by 1 unit, so what is going to be the value of y? So it's going to be the same for multiple linear regression as well. Okay, for this case, what happened is that, so when the number of item increased by 1, okay, so the y, so what is y? So y is the checkout time. So the checkout time, because the value over here is a positive, so meaning that when x increase, y is going to increase as well. So the checkout time will increase by this particular value, so which is 2.1825. And if you refer back to the question, so what is the unit for our time? So our time is going to be in minutes. So therefore here, so I'm going to write that this is going to be 2.1825 minutes. So that is going to be our interpretation. So basically, it's just what happened to y when x increased by 1 unit. So we're going to do the same when we interpret the other value as well. So we also have to interpret for the coefficient of household monthly income. So household monthly income, so the value is going to be negative 0.5445. So I'm going to write over here my beta 3. So the value is negative 0.5445. So the idea is still going to be the same. So I'm going to say that when the household monthly income increased by 1 unit. Okay, but the thing here is that you have to check for this particular problem, what is going to be our 1 unit. So our unit in terms of this, the household monthly income, the unit is given by RM 1000, meaning that 1 unit actually means RM 1000. So therefore I'm going to write RM 1000. So when the household monthly income increased by RM 1000, because 1 unit is given by 1000, so the checkout time will decrease by 0.5445 minutes. So this is what happened. Okay, if you notice, so the previous one, so when x increase, so what happened is that the y is going to increase as well. The reason is that because our coefficient is a positive value. But for B3, so what happened is that when the value of x increase, so the value of y will decrease because our coefficient value is negative. So the thing that you have to be very careful is that first you have to look at the direction. So if it's positive, when x increase, y increase. Negative, x increase, y will decrease. So that is what happened. And first, you have to mention the unit as well. So it's always going to be x increased by 1 unit, but you have to know what is going to be 1 unit of x. For the case of beta 2, so 1 unit means that you purchase one more extra item. So one extra item. So that is what I meant. But for this case, for the case of the monthly income, so 1 unit, because the unit is given by RM 1000, so 1 unit means 1000. So you have to be very careful when you are interpreting the. Okay, so that is going to be our regression coefficient. And the last one, so the question asks you to predict the checkout time. So if a customer purchased 14 items, so here, so they purchased 14 items, so the cost is going to be 210, and the household monthly income is given by 5,000. And again, for this case, you have to be very careful as well, because item is just item, how many things that you buy. So it's going to be 14, and the cost is going to be, so if we refer back to the question, so the cost, what is going to be, what do you call that? The unit for the cost. So for the unit for the cost, it doesn't really matter because it's just going to be in RM. But for household monthly income, the unit is going to be in RM 1000. So therefore, what happened is that when you interpret this, so this is going to be 14. So this is still going to be 210, but this one is going to be 5 because the unit for that is supposed to be 5,000. So it's going to be 5. Okay, next I'm going to substitute into my model. So I already had our model, so which is written over here. So let me copy this down. So I'm going to paste it right here. And I don't need this. So this is going to be our model. So I'm going to use this for prediction. Okay, however, you have to be very careful. So this is, I think this is kind of tricky question. So it looks easy, but that's a trick all over. So the first one is going to be the x1. So what is our x1? So our x1 is going to be the amount of purchase. So here, I am supposed to substitute over here by 210. And x2 is going to be the number of item. So here should be substituted by 14, and x3 is the monthly outcome in 1000. So therefore, this is going to be substituted by 5. So therefore, here I'm going to have 4.1350 plus 0.0229. So x1 for this case is going to be 210 plus 2.1825. So multiplied by x2. So which is going to be 14 items. And the last one is going to be negative 5445. So multiplied by 5. Okay, somebody calculate for me. So what is going to be the value of this? None of you have actually tried this. So what's the value?
Means the value is 36.7765.
Okay, 36.7765. And if you notice in the question just now, so it's written what is the unit for the checkout time. So the unit is going to be in terms of minutes. So please mention that as well. So meaning that if somebody actually purchased 14 items and he actually spent 210 for those 14 items, and the household monthly income is 5,000. So it means that on average, so we expected that the time that he going to spend at the mart to buy the stuff is going to be 36.7765 minutes. So half an hour to buy 14 items, so that's kind of long though. Okay, so that is going to be for number 5, and this is going to be the last one for this particular problem. So this is a summary. So this is called as model selection. So it says that the summary of the multiple linear regression analysis for the study is given by table 3. So complete the table for the 3 predictors based on figure 1, then select the best regression model for studying the checkout time by a customer. Justify your answer of the selection. Okay, so here, so as I mentioned to you just now, so when we have 3 variable, so there are multiple models that we can actually implement. So we can actually use a model with only one variable, so which is for this case, we can either pick only x1, x2, or x3 in our model. So it's going to be a simple linear regression model. Or it could be also that we need 2 variables. So it could either be x1 and x2, x1 and x3, and it could also be x2 and x3. But as I mentioned to you just now, when we have full model, so this is our full model for which we have all 3 independent variables. So this is definitely not going to be baked. We don't want this as our model. But as for comparison, then yes, we're going to write what is going to be the value of this particular table that we have to fill in. Okay, first, the question asks you to for the p-value. So why do you get the p-value? So the p-value will come from the ANOVA table here. So the value is going to be 0.0000. So I'm going to fill it right here. This is going to be my p-value, so 0.0000. It's sort of like telling you how useful this model is. And then we also need the value of both r square and adjusted r square. So r square and adjusted r square. So I'm going to take the value from here. So my r square is going to be given by a value of 0.8260, and the adjusted is going to be given by 0.7934. And the model is going to be given by whatever that we've written here just now. So this is basically going to be our model. So I'm not going to copy this down, but this is what should go here. So when I give you the solution later, so everything is written properly, but for now, I'm not going to copy it down. I'm not going to spend time just looking at those. Okay, so this is basically going to be the model that you're going to choose from. So we have how many model altogether? So we have 7 models altogether. And based on this, we are going to pick, so which one is going to be our best model. So how do we pick the best model? So remember the 4 criteria that I have explained to you in the beginning. First, small p-value. Second, high r square. The third one is going to be, what is the third criteria just now? What did I say
Don't
just
choose
now?
model with all the independent variable.
Okay, thank you. So do not choose the full model. And the fourth is that each of the individual variable that we have in the model, so they should be significant. So that is going to be the first criteria. Okay, based on from this, so we're going to do it first. I'm going to highlight certain places. Okay, these 3, they are simple linear regression. So I will not be looking at the adjusted r square, but I would be looking at the r square. So this is where my coefficient of determination value is. So you're not going to use r square adjusted because this is simple linear regression. Okay, however, the rest of them, so this is going to be multiple linear regression. So therefore, I cannot refer to the r square, but I'm only going to refer to the adjusted r square. I don't know as well. So why is it you are required to actually list out all of them? But this is how the question is asked. Okay, so now we're gonna have a look at this. So first of all, so let's have a look at the p-value. So from here, so I'm going to find which one has the smallest p-value. Okay, the one with the smallest p-value. So do you know what does it mean by multiplied by 10 to the power of -8? So the idea is going to be like this. So if I have 1 times 10 to the power of -3, so this is actually 1.0. So meaning that what happened is this decimal place is going to move 3 times to the front, 1, 2, and 3. So this is basically 0.001. So that is what I mean by 1 times 10 to the power of -3. And of course, if I have 1 times 10 to the power of -5, so I'm going to have 1.0. It moves 5 times to the front, 1, 2, 3, 4, and 5. So this is going to be 0.00001. So meaning by, so the bigger the value of the negative of the exponential, so the smaller the value of your p-value. So which one is going to be the smallest for this case? Of course, the one which has to the power of -8. So that is going to be the smallest. And then I'm going to sort of like spot this one. I'm going to hold on to that. And then next, I'm going to check the value of the r-square. Coincidentally, so this model also has the highest value of r-square. So compared to the rest, so this one is going to be the highest. So the r-square value is 0.8142. Okay, because this model only consists of only x2, and x2 has a small p-value, of course it is going to be significant. So therefore, for this case, which model that I'm going to pick? So it's going to be this particular model right here, so which has x2 in there. Yeah, how do you answer that? So you're going to say, so which model is going to be the best model? So I'm going to say, so the model with the best model is the model with x2 as the predictor. So meaning by the best one is going to be a simple linear regression, so which is given by this particular equation. Or if you don't want to say this, you can also copy down the model. So the model is going to be given by y hat is going to equal 2.1230 plus 2.5583 x2. So this is going to be our best model. So the question asks you to justify your answer. So why do you pick this one? So it's going to be very easy because it has the smallest p-value. So we want a very small p-value. It has the highest r-square. Okay, so that is going to be our justification. So that's how we pick that. Because it has smallest p-value, it has the highest r-square, so it satisfies the condition that we need. That's it. So that is going to be the best model. Okay, I think I'm done explaining things. For the next question, I'm going to start asking you. So how am I going to answer all of this? Okay, so this question number 5. So this is actually a final exam question from last semester, the latest one, 1920 semester 2. So the question said that the unprecedented increase in CO2 emissions has become an important global issue. So we're talking about CO2 emissions. So an engineer used a secondary data from the emission department to study CO2 emission in Malaysian road transport sector. So these are actually CO2 that is being released by cars, vans, anything that is a mode of transport. So the data records the CO2 emission. So this is going to be our y variable, our dependent variable. So the fuel consumption. So this is going to be our first independent variable. So our second independent variable is going to be the average of fuel efficiency. And the last independent variable is going to be the average of distance traveled for emission reading obtained from a certain region. So a multiple linear regression analysis is conducted and the Microsoft Excel output is given in figure 2. So when you come across multiple linear regression, this is always how it's going to be asked. You're going to be given an Excel output. So you're going to ask particular question about the Excel output, interpretation and such, and then you're going to ask to pick the best model. So that's always how it does. Okay, so now this is going to be the output. So this is how it looks like. So we have 3 variables, fuel consumption, fuel efficiency, and also the distance traveled. Okay, and our p-value is given by 0.0030. and this is going to be our R-square. So we refer to the adjusted because this is multiple linear regression. So it's a value of 0.8309. So those are going to be the most important information that we need. Okay, then in figure 3, so it says answer the following questions. So question number 1, how many samples of CO2 emission reading are used in the study? So how many samples are there based on this output?
Then
Okay, that's right. So as I mentioned to you just now, where do we look this information from? It's here. So we have how many observations are there? So the observation is equal 10. So therefore our n value is equal 10. So here we can write that away. So n equal 10. So that's already what you want mark. And then the question said that identify and interpret the coefficient of determination value. So the coefficient of determination, so that is going to be our R-square. So our R-square, so the value is given by 0.8309, and then all we have to do is interpret. I'm not going to write the interpretation because you know that already. So all we have to do is 83.09% of the variation in CO2 emission can be explained by this, and this. So that is how you're going to interpret the R-square. Okay, and then the question asks you to interpret the estimated value of regression coefficient. So now interpret the regression coefficient of the average distance travel, so which is going to be the beta 3. So where is beta 3? So this is going to be our average distance travel. So this is going to be our beta 3. So basically beta 3, so it's going to be a value of 0.0156. So we can see that when the distance travel, so the average distance travel, so increase by, so now when you wanted to write 1 unit, so you have to check back the explanation. So what is going to be the unit for this distance travel? So it's going to be in BPKM. I have no idea what does BPKM stands for. So I say, therefore, I'm just going to stay by 1 unit. So increase by 1 BPKM or 1 unit. So the CO2 emission, so will, because this is a positive number, so it will also increase by, so 0.0156 unit. So what is going to be the unit of our CO2 emission? So it's given by million ton. So you have to mention that. So it's going to increase by 0.0156 million ton. So that is going to be our interpretation. So when X increased by 1 unit, what is going to be the value of Y? Okay, and question number 4, it says identify the significant predictors based on the p-values in the coefficient table. Okay, now, so the question doesn't ask you about the p-value where we relate the independent and dependent variable, but we wanted to know from the predictor is our independent variable, so which one is going to be significant? I did mention to you just now, so where to look at? So where do we look at those values? Which p-value should we refer to for significance of each of the variable? Where should I be looking? So let's call this table as table number 1, table number 2, table number 3. So which table should I be looking at if I wanted to know which variable is significant individually, not as a whole?
The second, the
Table
third one.
3.
Okay, it's actually from table 3. So where from the table 3? So the table 3 has a p-value over here. So this is the p-value that is going to tell us individually, so which variable is actually significant. So which means that which variable is actually related to the dependent variable. So if it's not related, it's basically useless. So we need to remove this variable. Okay, so what you have to do is first, when you want to answer this question, have a look at the marks. So the marks is 5 marks. So don't simply say, okay, which variable? So it's going to be the distance travel. So if you give me that, I can simply only give you 1 mark. So there's a reason for the 5 marks. First, what you have to do is, so you have to list the p-value. So first, I'm going to have a look at the variable number 1. So what is the p-value? So it's given by 0.0147. So 0.0147. So what is going to be our alpha? So our alpha value is going to be 1%. So this is actually greater than 0.01. So therefore, so we do not reject because it's greater. So we do not reject H now. Okay, so that is what you have to mention. And then you have to do the same for x2. So x2, so what is going to be the p-value? So the p-value is given by this value, 6707. So that's a pretty big one. 6707. Of course, that is much, much bigger than 0.01. So it's going to be the same. So we do not reject H now. So this is basically a linearity test, like what we did for simple linear regression. And then x3, so what is my p-value? So my p-value for x3 is going to be given by 0.3249. Again, so it's going to be greater than alpha, which is 0.01. So therefore, what we have to do is, again, so we do not reject H null. So remember the linearity test? So linearity test is H null, our beta 1 is equal 0. And alternative beta 1 is not equal 0. So this beta 1 is actually our gradient. So when it is equal 0 means that there is no relationship between x and also y. But when it is equal 0, it could be positive, it could be negative. So there is a relationship between x and y. So as I mentioned to you just now, so when you get H alternative, then only your variable is going to be significant. However, for all these three cases, what happened is that we do not reject H null, meaning that H null is actually true. So what can I say about the significant is that, so none of the variable is actually significant. So therefore, none of them are significant. Okay, because all of them are basically pointing towards beta 1 equals 0, so which tells us that this variable, so none of them are actually related to the dependent variable. So basically this is kind of useless. So I don't know why we actually use this table for our prediction. Okay, so by writing all of this, like having all this p-value and testing them, and then writing so which one is significant, so that is going to give you a 5 marks. So please remember, so when you come across question that looks like this, so please mention the p-value, then only I can give you marks, so I know that where are you referring to. But if you don't put down what is the p-value, I have no idea. How do you find that significant? So you will only end up with the mark for the variable, so which is going to be 1 mark. Okay, and then the last one, you know already. So how do we get these values? I'm not going to show you, and this is not going to be in our what do you call it, our choice anyway. So this is going to be pretty much the same as the question that we have seen before. So we are been given this particular model. So we have how many? 7 altogether, like the one that we have seen before. And what happened is that, so we are going to pick, so which one is going to be the best model. Okay, why don't you have a look at this and tell me, like, which one would you pick? And let me highlight over here what value are we going to use. So this is going to be for simple, and this is going to be for multiple regression.
Miss, is that the E means exponent?
Yeah, that's right. So it's going to be exponent. It's 10 to the power of negative 5.
X1 miss?
You're going to pick x1? This one?
Yes.
Okay, that's correct. So even when I assess this, I would have picked the model with the x1. The reason is that, one, because, okay, let's rule out whatever that is not, what do you call it, not helpful. Okay, if we were to pick the one with small p-values, I'm going to rule out this one because this is kind of big. It's a value of 0.02. So this one is kind of big as well. And this one is kind of big as well. So I'm going to have x1, x1, x2, and also x1, x3. And then I picked them based on the r square. So if you notice, there's not very much different between the r square. Okay, however, if I have a look closely, I cannot pick a model with x2. So the reason is that because x2 over here, the p-value is 0.06, it's kind of big. So it means that this variable is not significant. Remember, only p-value small means that it's significant. So therefore, we cannot pick any model with x2. So I'm going to rule out this one as well. And therefore, we end up with x1 and also x1, x3. So if I were to compare between both of this, it's not going to be very much different because this is just 9.8 exponential to the power of -5. This is to the power of -4. And even the r square value is not that much different. But however, if you remember, I did mention to you just now, so our model, the simpler is the better. So therefore, if I have to pick between having a model with 2 variable and having the model with 1 variable, I would have picked a model with 1 variable. So therefore, yes, you are right. For this case, we would pick the model with the x1 as the predictor. So our model is going to be 10.7771 plus 0.0026x1. So this is going to be the best model. And of course, if the question asks you to justify, so just mention the fact that it has a small p-value and it has a large r square, So that's it. So that is going to be the justification. That's the reason why to pick that. Okay, and then the question, the last one said based on the best regression model in 5. So based on the model in U5, it doesn't matter which model you pick. Predict the CO2 emission when x1 is equal this value, x2 is equal this value, and x3 is equal this value. Okay, so this question is going to be followed through. For example, if this part over here, you pick this model, so it means that when you answer question number 6, it's going to be followed through. I'm still going to give you 2 marks if your calculation is correct, because I already penalized you here, so don't worry about that. Okay, for this case, I'm going to use this particular model over here. So with x1, so therefore, I'm going to have my predicted value is going to equal 10.7771 plus 0.0026 multiplied by x1, so which is given by 2889. So let's see if we have to choose this. So the unit is going to be in KTOE. So yeah, so this is already in KTOE, so we don't have to choose that. We can simply take it as it is. So therefore, I'm going to multiply that by 2889. And from my calculation, so I get a value of 18.2885. Of course, you have to mention what is going to be the unit of this. So we've seen this before. So the fact that this is going to be in million ton, isn't it? So yeah, here the unit of CO2 emission. So it's going to be in million ton. So this is going to be million ton. Okay, so that is going to be the value of that. So this is actually a lot of marks. So this is already 2 marks. So this is 3. No way this is going to be, because you only have to fill in this one. So that's 5 marks already. And this is 10. This is 11, 12, 14 marks. So basically when you have this question, so it's going to be 14 marks. 14 marks is a lot of marks for final exam. So I hope that whenever you come across a question like this, so you have the idea already. And what about this one? Okay, this one, the question is going to be a bit different from the previous ones that you have seen. So the only difference is that you are being given the output of each of the model. For example, here, this is called as figure 3. So we basically have 3 variables. Our independent variable is pressure, temperature, and also particle size. So yield is going to be our dependent variable. So this is going to be Y. So this is going to be x1, x2, and also our x3. Okay, so what happened is that they give you each of the Excel output. So for this one, so they only give you the Excel output with the bar, so with the pressure. So meaning that this is going to be the model Y equal beta naught plus beta 1 x1. So those will be the model. And then you are also being given this one, so which they include only the temperature in there. So temperature is our x2. So this is actually the model of Y equal beta naught plus beta 2 x2. And then we also have this one. This one only have particle size. This is Y equal beta naught plus beta 3 x3. And all 3 of them are simple linear regression. And then you also have this additional output over here. So now we include 2 of them, pressure and temperature. So x1, and x2 is included, meaning that this one is going to be multiple linear regression. And again, this has 2 variables, pressure and particle. This is temperature and particle, x2 and x3. And then they give you the last output for which you have all the variables. This is the full model. Okay, so what they want you to do is, what happened is that they ask you to fill in all the information for all the tables. So previous two questions, they give you like most of the table. You only have to fill in the last one. But for this one, you have to fill all of them on your own. And then you have to pick so which one is going to be the best model. And for this one, it's going to give you 9 marks for just reading the output. So it's going to be very easy. But I don't remember. So which one comes out for your exam? But it has been a while since this question is being asked because we think that 9 marks is kind of too much for like doing the same thing over and over again. So basically, if you know how to find one value for one figure, then you should be able to do the rest as well. So therefore, I don't think it's going to be something like this, but probably it's going to be more like the previous ones, for which that probably will give you like 2 or 1 row for you to fill in. That's it. Okay, however, so what is, let's see like what's interesting about the question. Honestly, nothing is interesting though. So those are already things that we have already discussed before. So I don't want to discuss that anymore. However, I find one very interesting thing about this is that, so this is what I already done for you. This is actually the mark scheme. I want to show you the table. Okay, this is going to be the table. Okay, now I want you to look at the table and tell me, so which one is the best model?
The sixth one.
Is it because I highlighted that?
No, because actually I want to choose the seventh one, but because of it is x1, x2, and x3, so I think that not cannot be included by the previous experience lah. So if according to the p-value and adjusted r, I think that x2 and x3 is better.
Okay. The thing is that when I first started doing my calculation on this, I also expected that the answer is going to be x2 and x3. So Janjan is right. So that's the right reason. So because here, so we have a very small p-value. So it's given by 10 to the power of -7. It's actually, in fact, the smallest out of the bunch that we have. And we have a very big adjusted r square, so which is 0.9018. Okay. However, so the answer is no. This is not going to be the best model. The reason is because of the fourth criteria that I have shown to you just now, that I mentioned to you, I explained to you just now. So the fact that when I pick x2 and x3, so I have x2 and also a variable x3 in my model. But the thing is that when I have a look at x2 individually, so this is going to be the value. So the p-value is actually kind of big. It's actually a value of 0.1375. So what does it mean by having a p-value of 0.1375? Meaning that x2 is not a significant variable. So remember I told you where to look at the p-value. So x2 is not a significant variable, so it should not be included in the model. So therefore, for this case, so which one is going to be the best model? So x3 is going to be the best model. Okay, so I know that sometimes when we have a look at the model, so this one is going to be the smallest p-value, this one is going to be the highest, but then you have to still check individually, so which variable is going to be significant or not. Any variable that is not significant, it should not be there in our model. So that is why for this case, so we are going to pick only the model with x3. So that is going to be our best model. Okay. So to be honest, I'm kind of tired already. I think I'm going to end here because I have explained to you pretty much everything that you have to know about multiple linear regression. So if you actually understand what we discussed today, so this is going to be, you don't have to do any more revision. So this is pretty much everything on multiple linear regression. But before we end, so do you have any question on this? So any part of multiple linear regression that you still find that confusing? Anything that you want to know related to the topic? Okay, if you don't have, yes, Ame?
For the regression coefficients,
Okay.
when nak kata macam mana?
Apa dia? Cakap Melayu.
Ya, Melayukan je lah kejap.
Cakap Melayu. Sekejap ya, I interpret.
Contoh unit tu macam kata yang question 5 kan patut dia guna PKM tu kan.
Okay.
Dan unit tu kan kita tak tahu masa dia guna unit apa maksud unit tu. So boleh ke kita letak satu je? Contohnya macam kita tak tahu apa kilometer tu. So kita letak 1 kilometer je ke?
Dia instead of letak 1 kilometer, kita letak dia 1 unit lah. Dia kira 1 unit.
Sebab macam tadi kan dia 1000 kilometer yang question first tadi tu kan.
Yang tu you memang kena refer balik unit. You have to refer back to the question and tengok dalam question tu apa dia punya unit.
Okay.
So Amir, your friend over here, so he asked me like in terms of the regression coefficient interpretation. So how do we have a look at the unit? What if we don't really know what does the unit means? For example, the BPKM just now. To be honest, I have no idea what does the BPKM stands for. But the thing is that all you have to remember is that so it's going to be when x increase by 1 unit. So 1 unit, for example, if I were to refer for this, so 1 unit of this is going to be 1 degree Celsius for temperature. So 1 unit of this is going to be 1 millimeters. Okay, and so that is how you read the 1 unit. And if we were to refer back to the problem just now, so for which the BPKM come from, so it means that if I have 1 unit, it's going to be 1 BPKM, 1 KTOO, 1 kilometer per liter, and so on. But if this one, it's going to be 1 unit means 1 million ton. So basically your 1 unit, you only have to refer to the unit that is given. If it's written in RM 1000, so that's not how it's written like this, RM 1000. So meaning that 1 unit is going to be 1 RM 1000, so which is going to be 1000 ringgit. Right, so anything else?
Doctor, I would like to ask about the quiz.
Okay,
What
about
it's going
quiz.
to be.
Yeah, I was about to address about that as well. Okay, the thing is that I can do the quiz. So if you notice, we have like, how many chapters do we have altogether? We have 6 chapters. So this is going to be the 5th. So we are done with chapter 5. Okay, I will give you, what do you call this? I'm going to leave it up to you. So this Thursday, do you want us to revise chapter 6 or do you want us to do the quiz? So meaning that you're going to do a revision on chapter 6 on your own. So I will leave that to you. So what do you want? So if you think that you don't need revision for chapter 6, then we can do the quiz on Thursday because chapter 6 is very easy. So there's going to be just a bunch of calculation.
Miss, if we do the revision of chapter 6 by our own, will Miss provide the materials and also any videos, or we just follow the basically video from the Kalam provided?
So if we don't do revision on that, I expected that you would, I can give you the notes, but I expected you to watch the video, then I wouldn't do the video.
Oh.
So which one do you want? So choice number 1, so we'll do the quiz on Thursday. So you will do revision on chapter 6 on your own. Choice number 2, so you will do, we will discuss chapter 6 on Thursday and we will do the quiz probably on Monday next week. So I will do the quiz and I will open, for example, like 2 hours. For example, at 9 until 11 p.m. and I'll give you the chance for you to do during the 2 hours. So which one do you want?
I prefer the choice number 2.
You prefer choice number 2. What about the rest of you then?
Number 2, Miss.
Okay.
Yeah, I prefer the quiz will be next week and then the chapter 6 revision will be this week.
Okay, sure. Okay, so let's do it that way then. Okay, what happened is that, so we will revise chapter 6 on Thursday. As I mentioned just now, chapter 6 is pretty easy. So it's just a bunch of calculation. And the quiz, so the quiz is going to be on simple linear regression. I will prepare the question and you will do it on Monday. So I'll open it during, I will leave to you to decide on the time, but I will open it for 2 hours. Okay, so I think we should end here for now. I will, of course, send you the notes and such, and I'll send you the recording as well if you need it. So let's end here for now, and I will see you again on Thursday for the last revision. Okay, I'll see you guys then. Bye.
Thank you very much, Doctor. Have a nice
No
day.
problem.
Thank you, Miss.
Okay.
Thank you.
No problem.